Okay, so welcome back to another video. So here today we have a simple natural log based algebraic expression, and we want to solve for x such that 2 to the power ln of x, add this with ln of x to the power ln of 2 is equal to 4. So yes, I did say simple because I know that we have like the natural logs functions in our equation, that it may look a little bit confusing to find the variable itself with this jumbo of mess, especially since the natural log is being put as part of the exponent and you have another one as part of the base. But to put this simply, all you have to do is really, if you just use your rules of natural logs with its properties, especially since in the first step, I'm going to give this away right now. The first step is we see that the base 2, you can also write that as e to the power ln of 2. So in other words, it's actually a good way to start there and then manipulate the rest of the equation from there in order to solve for x. So yeah, nothing more to be said. It's actually a very simple algebraic expression. We want to find x. Don't take this too, I wouldn't make this too overwhelmed. Don't make it too overwhelming on yourself when you see something like this. It's just think of something clever tricks that you can manipulate with the numbers, especially that you can actually solve for the variable itself. So that's something that you usually see in these, practice problems when they teach you this. Well, maybe if they did, but anyway, let's actually just jump in. So first step, I did give away the first step. We can write 2 as e to the power ln of 2. Then everything will still remain the same. So we have ln of x. Add this with ln of x. Then ln of 2. Set this equal to 4. Then if we know by properties of with exponents, because when we have a base raised to the exponent and exponent raised to the exponent, basically it's just multiplications of exponents, and it's commutative. So in other words, we can actually interchange these and commute those. So in other words, I can actually move the ln of 2 outside and move the ln of x inside to our exponential base. So I have e, then ln of x, then ln of 2. Add this with ln of x to the power ln of 2, set this equal 4. Then we see that the e ln of x, obviously that'll get rid of itself and we're just left with ln of x, then ln of 2 plus ln of x to the power ln of 2 equal 4. But hey, guess what? They share the same base. Well, they share the same thing, so that means it's double the quantity. So I can say 2 times ln of x to the power ln of 2 equal 4. And if we just divide 2 to both sides, then therefore I would have ln of x to the power ln of 2, and then set this equal to 2. Then again, just by using, well, actually not there yet. So what we can do now is let's actually take the natural log of both sides. So this way we'll have the natural log of x to the power ln of 2, and then set that equal to ln of 2. But of course, with natural logs just like this, by using properties, actually the way I wrote this, the ln of 2 should be inside the expression, not outside of the parentheses. So ln of x to the power ln of 2, and then we can close that parentheses off. And now further implying that by using the your logarithmic properties, you can move the exponent outside in front of the natural log. So therefore, further saying that we have ln of 2 multiplied by ln of x, and then set this equal to ln of 2, which is nice that I can actually divide ln of 2 to both sides, and so we're just left with, so I'll put this arrow over here. So further implying we have the natural log of x, set this equal to 1, okay? Then just simply, to get rid of the natural log itself, we can actually just exponentiate both sides. So therefore this is e to the ln of x equals e to the 1. That'll get rid of itself. Then we have ln of x equals e. Do the same thing again, just take the exponentiation to both sides. So e to the power ln of x equals e to the power e. The e to the ln will get rid of itself, and so therefore we have just found x, our x that we want to find for. Therefore the only solution is that it's x is equal to e to the power e. And so there we have it. just like that, we are done for finding our solution satisfying the given algebraic expression revolving around natural logs. So yeah, pretty simple. Again, as mentioned, you don't overwhelm yourself with just because you see a bunch of natural logs. I know natural logs can be scary, especially when you're learning this and how to manipulate things, but if you put it this way, use these clever tricks, you'll get eventually what you want to achieve. So yeah, that's pretty cool if you ask me.